Hi, this is Xavier with the AP Calculus BC 2013 number 6 FRQ. So here's the free response question. It has three parts, A, B, and C, and it states a function f has derivatives of all orders at x equals 0. Let p sub n of x denote the nth degree of a Taylor polynomial for f around x equals 0. Part A says it's known that f of 0 equals to -4 and p sub 1 of 1/2 is equal to -3. Show that f prime of 0 equals 2. Part B says that f double prime of 0 equals to -2/3 and f triple prime of 0 equals 1/3. Find p sub 3 of x. Part C says that the function of h has first derivative given by h prime of x equals f of 2x. It's known that h of 0 is 7. Find the third degree Taylor polynomial for h around x equals 0. Alright, so after viewing the problem, let's use our intuition to draw out some initial thoughts. This FRQ doesn't look very familiar. It asks, some things that we're not usually doing in class. So a new looking format. We haven't seen this type of problem before. Don't worry though, we can work this out. Definitely involves Taylor polynomials, as is stated a couple times in the problem. And it's probably, so by that logic, it's probably good to know the format of a Taylor polynomial and how it works. And since it says x equals 0, it's actually a Maclaurin series. But that doesn't help us extremely much here. And it involves evaluating functions where you plug in things and they set them equal to other numbers, and probably going to involve solving some functions. And knowing your derivatives, and antiderivatives relationships, like how they work, such as seen in part C, as we'll see later. We will have to find some antiderivatives and know the relationship between that and derivatives. Alright, so let's get to attacking part A. Here's the question, and we should start by, it's known that f of 0 equals -4. So we should use the Taylor polynomial formula. Here it is. And the -0 is just so that's a Taylor polynomial. It's actually a Maclaurin series, so you don't really need that -0. Alright, so what we do first is, here's our p of 1 from part A, from the problem it's seen, and we take that out, and we plug some values into it, just like we solve an equation, except this equation just happens to be a Taylor polynomial. And with this, we simplify it, and just like an equation, we solve for f prime of 0, since the problem asks us to show that f prime of 0 is equal to 2. And with that, we find that f prime of 0 equals 2. And here we have it. We proved it just by plugging things in and solving the equation, just as we would with any algebraic problem. Alright, so we should now attack part B. Here's the FRQ, and it says it's known that, we've read that already. Find the third degree Taylor polynomial of p of x. Alright, so once again, we take out a formula, probably need that. We take the segment we need out of it, so p3 means it's a third degree Taylor polynomial, so that's the segment we need. And then we can start plugging in values. We know -4 from the previous problem, and 2x occurs from plugging in the value from up there, from part A again. It says f prime of 0 equals 2, and we plug in everything else. This, f double prime is -2/3, and so on, into the formula of a Taylor polynomial of third degree 1. And after some simplification, which is algebraic, we get the answer, which is a nice Taylor polynomial. This is our p sub 3 of x. -4 plus 2x minus 1/3 x squared equal plus 1/18 x cubed. Alright, so part C. This is probably the most difficult one, because it's not something that we can just, automatically know to use algebra like the previous two. Segments of the FRQ that was required. So, it has a relationship h prime of x equals f of 2x, and it's known as h of 0 equals 7. So we got to find h. Now, what's the relationship between h prime of x and f of x? So we should recognize that this is a relationship they're giving, and so that means that the f is basically the derivative of h of x as given. So in order to turn it around, we would have to find the, that's right, we would have to find the antiderivative, because we're working the other way around. So we plug in the 2x, so we get q prime. That's basically just plugging in, this is our f2x. And then since we have h prime of x and we're trying to find h, we solve for the antiderivative. We antiderive this Taylor polynomial just like we antiderive any other equation. And we have some plus c's, right, from antideriving it. We sub in h of 0 equals 7, the initial condition that was given to us in the problem. And voila, we have our third degree Taylor polynomial for h, which here is q sub 3 of x, which is 7 minus 4x plus 2x squared minus 4/9 x cubed. So this one required a little bit of intuition, but once we recognize the derivative and antiderivative relationship, we can easily plug in 2x and solve. This can also be done with another way, where you find each value independently through plugging in each of them and putting it together at the end, and that's also a very valid method. Okay, so here's some mistakes. In part A and B, if you can't recall the Taylor polynomial formula, that's probably a problem. Another problem could be like recalling the formula incorrectly. For example, forgetting the factorial under the coefficients. That's relatively common. And another mistake could be calculating algebra incorrectly, or simplifying the equation incorrectly, such as like misunderstanding what a factorial is, or missing like a fraction and accidentally simplifying it wrong. It's also a possible mistake. And also having no idea how to do the problem. That's, I don't want to say it's common, but I guess some people also have that kind of issue. And to get points on these kind of problems, really, you just need a, sort of, unless you were totally not paying attention in class, you should be able to slowly, like, it's a series, right? The Taylor polynomial. So you should be able to pull out some sort of, like, try to figure some sort of equation out. But if you can't, yeah, you're in bad luck. But the scoring guide does give you points for finding certain derivatives. And so just recalling them and like for example in part C, knowing the relationship between the two, you can already get 2 points by writing out the 2 terms you solve for in part B. So points are not difficult to get on this problem. And in part C, you can, calculate the antiderivative incorrectly, which is, sort of a problem because that's Calculus AB stuff. You might want to go back and review that if you have trouble. And also forgetting 2x when evaluating for function h, since if we go back really quick, it asks for h prime of x is equal to f of 2x, not f of x. So read the problem, know what you're solving for. Some general tips. All right, so some FRQ-related resources for this FRQ. This problem was actually mainly algebraic calculations, like plugging things into a Taylor series and then evaluating it to, prove one, like in part A, prove something in part A, or like finding out some sort of relationship between derivatives in part C. And so there isn't much to talk about, but here's some general review. The textbook is a great resource, section 11.10, sorry. That especially talks about Taylor series. Here's some problems on Taylor and Maclaurin series, and mainly other practice. Other BC FRQs are stated as here, 2003 number 3, 2008 B number 6 is also very good, and the rest you can check out yourself. And also Mr. Happ's chapter 11 FRQ worksheets are very, very helpful. There's a whole document Mr. Happ compiled for just Taylor series practice and other series like that. And they might have other content, but they definitely have Taylor series. That's a critical skill. Taylor series are very important, and it's not extremely difficult, at least not in this, as you can see in this FRQ. All you have to do is plug in values and solve. Like the intuition should have come from algebra skills. That's sort of this problem. And probably should go back and study your algebra if you had trouble attempting to figure out what you had to do for the problem. All right, thank you so much for watching, and I hope you learned something.